Hello everyone. This is Hayashi from Intel DPD of SSG. Today, I will present System Studio use cases for DSS, digital security and surveillance. So the slides itself a little big, and probably I cannot spend time in detail to explain every slide. So if you have any question, you may stop me and let me know so I can go more in detail for you. Okay, so first, this is the block diagram of the end-to-end digital security and surveillance system for development on IA platforms. And the System Studio is utilized to develop the DSS application and the system. So what's inside of System Studio? Here is the block diagram of the ISS Intel System Studio. So we separated the System Studio into 3 categories generally. From left side, computer performance, computer system, embedded system performance improvement with compiler and libraries. In the middle, several kinds of analyzers for performance, power, and memory threading, analytics, analyze. And the final is debug for both system and application debugging, including trace capability. So for overall IA platform, all are supported by System Studio, and there are a lot of major target OS are supported by System Studio as target. For host, we do support Linux and Windows. Here is a general flow of DSS application and system development. So you may develop the software with Intel compiler and performance optimized libraries. It's part of Intel System Studio as well. On IDE such as Eclipse or Microsoft Visual Studio. And then you can use analyzers of System Studio to check your application or your system performance, power consumption, and check the your application robustness. Robustness is also important as a system solution. And also you can use GPA to check GPU performance as well. And the last piece is debugging and tracing. So for application level and system level, we both supported trace and debug. We have extended the GDB with the processor trace feature, and also support Windows as well. As for system debug, I will introduce more in the slide later. If you have any question, I will answer you later. So here is a use case from HiK Vision. This vendor developed the application digital surveillance video recording. So there are several challenges at the beginning. Needed to deliver high performance code that can process multiple channels and the resolution of the video data to be recorded. It also needs to take advantage of both CPU and the GPU. And next, need to build the stable and reliable code that can enable 1 week video recording. So what's the solution was offered? That is System Studio and the Intel Media SDK. With System Studio and the Media SDK, can provide analyzed threading synchronization issue using VTUNE'S AMPLIFIER. It's part of the System Studio. And fix issues to reduce CPU usage. Also, can check memory problems with Intel Inspect. It's also part of System Studio to improve the code quality for robotics, for robustness. And also can achieve fast video code through using Intel Media SDK and IPP, Integrated Performance Primitives. It's a library of System Studio. So what kind of the business value Hi-K Vision achieved as a result? Overall, about 20% CPU usage reduction was achieved, and improved performance and resource utilization. Second, was able to offer reliable and high-performance network video recorder devices. Here is 2 more use cases. One is from German telecom. As a result, they achieved 3x better performance, power efficiency. And one more is also from network video recorder vendor, Daihua, who achieved 50% performance improvement. Okay, for now, I will introduce the domain, what can improve with the System Studio. So I will go through analysis, performance, optimization, and debug. So firstly is analysis. In general, to do analysis, first we got questions like, can I add more video streams or increase video resolution in our smart camera systems? And also like, is the CPU and the GPU workload balanced? Or too high CPU usage in a video gateway, want to reduce the usage? Or why? What's the problem? The low resolution video take more computation resource than the high resolution. Also, like, why does the threading overhead go so high after add more video streams and somehow more? So the solution can offer is to utilize Intel VTUNE'S AMPLIFIER. Can do fast, scalable code fast. So first, can get the data what you need. For example, like we can get hotspot, core counts, and also can get thread profiling result, and the cache miss, bandwidth analysis of I/O, GPU offload, and OpenCL kernel tracing. And the second benefit can find the answer quickly, shortly. View the results on source assembly view. And for OpenMP, scalability analysis, video frame analysis, or like filter out the extraneous data, organize data with viewpoints. Also, like visual thread and task activity on the timeline for check. And this VTUNE amplifier is also very easy to use. No special compile is required. And Visual Studio integration or standalone both are supported. Also can do local or remote data collection and command line support. Analyze Windows and Linux data even on OS X10. So what kind of analysis can do with VTUNE amplify for system 2018? For example, needed to find out the spending time in your system, or to find out the wasting time, or to find out why waiting too long, and also to find out the wake up, why so many wake up. So remove the wake up can achieve the performance, and also can especially for low power design. Here is one sample how to do analysis with VTUNE using the multiple transcoding sample running on Intel Atom processor E3900. Formal code name Abrodic. And the data is 64 video stream for both decoding and composition. This is the VTUNE screenshot, and you can see on the top half, you can get the function, all of the functions of the application under analysis, and you can find out which function is take CPU time more. From the bottom half, listed all of the threads tied to this application, and also you can see from the timeline, you can see the both GPU and the CPU usage. So what to do with VTUNE amplify? For example, can do advanced hotspot. So the advanced hotspot, you can find out the problem consuming CPU time. For example, here pointed out the lock function. So there are two lock function, like the second function and the fourth function, both are lock function, and take CPU times. So I need to optimize these functions, especially highlight the in pink. That means it's not efficiently. Bad CPI rate, cycle per instruction rate. So from the bottom half, you can check each timing the CPU resource. This is 4-core system, so the total CPU time should be 400, and in general more than 200% CPU time is consumed. So to tune the performance, first look into the remarkable the look function, and make a click on the arrow, and you can get the list of the call stack belong to this function. And then you can see the detail of the call stacks, where the locks are used. And then double click the function, and you will be direct to the source code. And the problem here is with MSDK sleep. So what this is doing is take 1 millisecond sleep, and then go back to make a request again. Since this is 64 channel application, so every channel make request looking for a chance to be processed. For every millisecond, it will causing unbalanced result. So here is proposal is to make the sleeping 1 millisecond large number to improve the performance. So from the top, you can see originally it cost more than 200% CPU resource. So after change the sleep time from 1 millisecond to 30 millisecond, then reduce the CPU usage to about 174%. So with the VTUNE amplify, achieve the performance improvement easily. And also you can do analysis for both CPU and GPU. Next, discuss how to do performance optimization with compiler and the libraries. We do have a solution, Intel IPP, Integrated Performance Primitives. Here is 6 categories, but in general, image processing libraries and computer vision libraries are used by DSS development frequently. Here is the IPP use case. So with the open source computer vision, is a library of the programming functions for real-time computer vision. There are 2 ways to utilize Intel IPP into OPENCV. One is IPP ICV package, and another is standalone Intel IPP library. So what's the benefit with IPP? Here is the use case. With the IPP, you can see can achieve the better vectorized implementation. So IPP is a library developed by Intel with optimized functions, which can deliver better vectorized calculation. So here is the graph to show the performance of the IPP compared to the standard OpenCV without IPP. And you can see from horizontal, more use cases with the zooming can achieve better performance with IPP compared to the OPENCV without IPP. And the result is similar on both Intel Atom and Intel Core architecture. Here is the performance of the Intel compiler compared to general commercial compiler and also open source compiler on GCC. And you can see on Atom Xeon platform, both floating point and the integer calculation. The Intel compiler always deliver the better scores. So the last piece is debug and locator problems. In general, you can get these questions. How can I find the memory leak in the code from different project teams? Or how to reduce the memory usage to support a system with strict memory? Or how to measure memory growth to create a stable system running on multiple months, or debug tools to help locate the system level code problems. First, we do have inspect. It's a tool for memory and thread debugging. First, it's a correctness tool improve ROI about in general 12% up to 21% on case by case. And second, can offer debug integration, speeds diagnosis. So it's kind of like give a breakpoint set just before the problem, so you can measure, identify the problem. And what's new in 2018 version? In 2018 version, we do have features like fewer false positives, and also C++17 standard shared mutex edit, and also support Windows SRW locks, slim locklite. It's used to support the thread, the shared source. Here is the usage sample of the inspector. The problem is the memory on the camera devices decrease significantly after the code runs several hours. It's kind of a situation user may encounter frequently. So with Intel inspect, you can edit command on embed target to record the memory growth and the leaks. And inspect reports how much memory is leaked and where is the problem located. So here you can see the problem with the ID. So you can create the use the inspect to check the memory thread, and each function, each check can be identified. For example, using inspect CL -C reset growth tracking. Then can clean up and set the restart point, and then with measure growth, so you can get the memory usage, and also inspect report the detailed memory usage in different exception cases, and also reduce the memory usage to meet structural memory at devices. Also, we do support debugging with Intel debug, and from different topology, especially recently offer closed share sheet USB debugging with low cost. Like for example, you can use debug USB cable, simply connect the target and the host for system level debugging, or for BIOS OS kernel debugging. And also we do support core platform debugging with CCA blue box right side in the bottom, and it's also connected between the host and the target by the USB 3 debug cables. So both support traditional JTAG run control, and also offering processor tracing, processor instruction tracing, and system trace. So here is the screenshot introducing another tool, system trace tool. It's also part of Intel debug over Intel Systems Studio. Can efficiently isolate the issue root cause, and also can analyze the complex interactions between software and hardware. This is a screenshot of the system debug. Support JTAG run control, and for BIOS debugging, UEFI debugging. All right. Since I go through the three major category for development covered by Intel System Studio, how to do analysis, how to build and optimize your codes, and how to do debugging, and robot test code checking. And here, I'm introducing you Intel System Studio 2018. And currently, we have a beta program, and System Studio 2018 beta version is released on the website. Everyone can easily register and then download the beta package to evaluate and test on your system. You can pick up both host, Windows host or Linux host for your specific target system. And also there are 4 ways we offer for you to share your feedback with us. Okay, next I will answer your questions. Okay, I got a question. The question is from user developing a solution using Raspberry Pi 3 and OpenCV. Face lag in video and OpenCV output. Can the user migrate to Intel-based solution? So can give the user a perfect result. How much the budget impact will be there? Yes, it's possible to migrate your solution to Intel-based platform. What you may need to simple answer you can do the migration. So for the budget impact, well, depends on the level of your codes. You may use you may put in your software, your application to IA platform with Intel compiler or GCC, but I do recommend Intel compiler because Intel compiler in general can provide high performance. And it's hard to answer you the budget impact because you have your you must have your targeted performance target. So for example, you may just simply use GCC to compile your codes and test it on the IA platform. But if the result not meet your performance target, then you need to optimize the performance. You can use if you didn't use Intel compiler, you can try Intel compiler. Simply just try Intel compiler. And if you still cannot achieve the performance target, then you can use several switches specific for code to optimize the compiling performance, and also specific optimize for the target Intel platforms. And if you still see problem not meet your performance target, then you need to use VTUNE AMPLIFIER to analyze your application, or even analyze the whole system. The sample I used within my presentation was analysis with application, but VTUNE also do support process and system level analysis. And use VTUNE to amplify to identify the hotspot, and then look into your source code and optimize the performance, and then compile again and test again. If you still see a problem, and then use VTUNE again. Okay, here's the question. There are computer vision API available where we can send the image and get the objects recognized. In this context, what is the need of the developing code from scratch? If you have depends on the performance. If the performance meet the goal, then you don't have to develop or make a modification. Okay, I have two questions. Let me answer the first one. Send image of the car and send it to Global API. It will give me the result with the number of car presented. Well, it's just kind of if I understand your question well, you may just check the performance target whether the computer vision API give the performance as required, and with the VTUNE amplify, you can look into the API function and check the. If not meet the goal, then you can optimize the API function. And the second question, what are the modern protocols that allow data interchange with connected device that Intel provided? Well, this is out of the domain of the Intel System Studio, but you may check the datasheet or EDS external design spec of the target platform, IA platform, your design, to make sure what kind of protocol do support it. And from System Studio perspective, can analyze, can use, for example, can use VTUNE amplify or using GPU to analyze the data interchange. And even, for example, if the data is goes through the PCIe, PCI Express, we can also do supported PCI Express analysis. Or if it goes through the disk or even memory, we can also do support disk I/O and the memory analysis. In the next question, what are the different developer personas targeted for this computer vision flow? In general, application developers who are developing security surveillance software application. And the second is OS developer for the targeted system. For example, we offer system debug for kernel for OS kernel debugging, and also the target audience will be system developer for the whole security surveillance system development. You can use, for example, you can use VTUNE and analyze your whole system, or you can use system debug to debug your system, identify, isolate the issue. Also, we do have a SOC watch, Intel Energy Provider, to check the system and without any hardware. For example, you can measure the your system power consumption. Again, software application developer, OS system developer, and also system developer. So all of the developers for both software and hardware development of the DSS system. Without this, Intel System Studio, you still can develop your software, develop your application. But with Intel System Studio, you can spend few time with a low cost and easily to develop your application, your OS, your system, including the hardware. And System Studio itself is a cheaper solution because we are semiconductor vendor. We are selling silicon. We are silicon company. Is not selling System Studio as a key for business success. You can see the revenue of you can imagine the revenue of System Studio is nothing compared to the silicon sale. So this is a cheaper solution, can help you to develop your software application, your system quickly, easily, fast, and efficiently for both performance and power optimize. There are computer vision code samples integrated in ISS, or where can I get more CV samples for ISS? Well, there's no ISS is not specific for any ISS is not designed for any specific CV applications. ISS can be utilized for any samples, any CV samples. As for ISS itself, we don't. We have some samples, but not specific for computer vision. As well, I would say there are a lot of samples offered with ISS together. Help you to understand the usage of the ISS components and how to use the each components. Media SDK. Well, a little out of the coverage of this session. Media SDK is another development tool offered by our DPD. The many media SDK is targeted for media application development. For example, if you need to do H.265 video application, and you can use the Media SDK API to code the H.265 codec of integrated within GPU. Question: can you explain more inference in this solution? If you're asking what's the inference of the system, if you want to get more inference of the system studio, Intel System Studio, let me try. So System Studio includes many kinds of development tools can help developers who are doing digital security and surveillance application, software application and system development to use these many kinds of tools within Intel System Studio to build your application with optimized performance and power in short time, and with much robust advantage, securely, reliable as a solution to be offered to your end users, and also can help you develop your application system cheaply. Because Intel System Studio is a software tools without any hardware equipment is required for debug, like the debug hardware, ITP-XTP or CCA or debug USB cable is required, but it's very cheap. Like debugger USB cable, you can get from Intel website with $10, $10 US. Thank you. I believe it's time. And again, thank you for your all attendance. And it's my pleasure to deliver this session to you all. Goodbye.